wish you were too.
So. And when it comes to hydrochloric acid, a little less than half way up the tube is really all you need. And I put the Petri dish on top just to keep the fumes from going around and making things awful. And this balloon, hopefully it's tight enough, is it? Yeah. Get it over the top. Turn it so they can see. And then we let the reaction go. And I might show them on a whiteboard behind me or something if I've got it handy, the actual equation for what's going on. So you have ZnCl plus, or Zn plus HCl yields H2 and then ZnCl. So you get basically like a zinc salt, so to speak. And that balloon's a little smaller than I was anticipating. Hopefully it won't pop.
We have a lab at Wayland that I've done that does the same thing where you put it, you have a hose and you've got a sidearm flask, you put the zinc in, and you put your hydrochloric in, and you hook up the hose to a 3-liter bottle with the bottom cut out.
Right.
And so you make that hydrogen gas and then you light it.
That's what I'm about to do. Yeah. I'm creating all kinds of things. So we have some tape floating around in one of those boxes. Someone's going to a box and have some tape on it. I make a very high-tech device called a match on a stick. And with this match on a stick, I'll just get a piece of tape. Out of the other boxes. Yep. Excellent. Oh, here we go. Just this little piece. This right here is great. And then for theatrics, at this point, I'll go ahead and try to get the balloon off of the test tube. And mind you, this is an extremely exothermic reaction. Down here at the bottom of the tube, it's hot, like real hot. OMG hot, if I were talking to my kids. Yep, OMG hot. The acid at this point is much more diluted than it was. So if you feel a little moisture, more than likely it's just condensation because of the heat, so don't panic. Okay. Yeah, I'm going to have to let that sit a second because it's still reacting really good. So just with the theatrics, I'll get it, I'll tie it off, put a little knot in it, and I'll set it down in a clear spot, and then I'll tell the kid, I'll get a volunteer, okay, I'm going to give you this, I'm going to light it with the box, and then you're going to come over here, and you're going to take it, and you're going to ignite it, okay, right near the base. And as he does that, I light it, and then I take off to the corner. And I duck and hide. I'm not doing this. And kind of try to calm them down. It's okay. It's not a big deal. And then they come up and they light it, and then everything's great. They do it all. You get a nice little fireball. I'm going to let that settle for a second, and then we'll get the gas out of it, and we'll move on to the next reaction as this is settling out. This next one takes two chemicals that more than likely, unless you are a chemistry teacher, or have good access to a chemistry teacher, you may or may not have, so I have an alternative. This is ammonium thiocyanate. Say that 5 times fast. Ammonium thiocyanate. And then this one's barium hydroxide. Barium hydroxide and ammonium thiocyanate give us a very lovely reaction.
And he's going to make a materials list for each station, and so you'll have the list of those chemicals, so you don't have to try to figure out how to spell it.
Gosh, surely they can spell ammonium thiocyanate.
I will also post the videos that I'm taking, so that you'll have videos of the reactions and stuff to remind you how to do it.
We still have paper towel.
There's some burnt in your dish.
Yes. Well, I've got the dirty one.
This is good. Now, I don't recommend you cross-contaminate like I'm about to do, but my barium hydroxide's almost out, so I'm not terribly worried about it. I've got fresh at school. So I get a spoonful of both, and I ask the kids before I actually mix them about the physical properties of each of them. They're both kind of small, crystalline powder in nature, and then just visually glancing at them, you can't really tell much of a difference between them. Mix them together, start stirring it up, and they're going to begin to react together, and they start forming a slush, and then eventually a liquid. You can kind of see how, especially down at the base, they're starting to congeal. They're making a gel, and it's letting off a gosh-awful gas. Ammonia, basically, is what it's letting off, ammonia gas. So I will caution the kids, because I'm about to pass it out and let them feel the bottom of it. As it's reacting, don't take a sniff of this. Don't whiff it. Okay, you might waft it if you're that curious, but it's going to sting. Okay, try to avoid it if at all possible. And for theatrics, and I won't do this now just because for the sake of time, I'll put a piece of wood down with a couple of drips of water on it, and then I'll set this on top. This is an endothermic reaction strong enough to actually freeze water. So I'll hand it to you and let you pass it around. Feel the bottom.